Hello, welcome everyone to my new video where I'm going to show you how you can use AD converters in PIC with the PIC microcontrollers. In this video I didn't want to make an intro with the development system because it was really hard to record all that. So I'm just gonna show the program over here. So here I'm going to have 5 LEDs on the output, and I have one analog value on the input to the PIC microcontroller. So the project let me just begin from the 0 volts over here. So you have a potentiometer here, and it's like a voltage divider. Between 0 and 1 volt, if I have between 0 and 1 volt over here, then the the pin RD0 is gonna be high, and this LED will glow. So this is like a LED voltmeter. If I have 1 volt on the input of the PIC microcontroller, then RD1 is gonna go high. So between 1 and 2 volts, I'm gonna have this second red LED diode glowing. Between 2 and 3 I have this LED diode. Between 3 and 4 I have this LED, and between 4 and 5 I have this value. So it cannot go above 5 volts because the nominal voltage of the microcontroller is 5 volts, and I mean it shouldn't go higher than 5 volts. So let's start with some theory. Okay, you know that analog value is or an analog signal in electronics, for example, is a voltage level that can have any value at any given time. Digital values digital signals have only specific values in some discrete times. So, for example, you can have any value between 0 and 5 if it is an analog value, but you cannot have you have specific steps that this analog digital value will grow. Okay, I don't want to go in heavy details. I think you should know. I said you have to learn a little bit about electronics before you start programming PIC microcontrollers. So I hope you know. I hope you understand the basic principle of the AD converters. But and I just want let's say what is the most important thing to look at when you have PIC microcontrollers, and if you want to make an AD conversion. First of all, you have to see what is the resolution of the AD converter. If it says it can generate a 10-bit binary number, that means that you have 10 to the 10th possible combinations on the output. So that 2 powered by 10 is equal to 1024. So that means that you can have 1024 binary combinations on the output of the AD converter. And here it is, as you can see, from B0 to B9. So it is a 10-bit long binary combination which you can have on the output of the AD converter. So okay, so that was the first part. First thing, you should always look what is the resolution of the AD converter. The second thing you have to look, or how do you say? Sorry for my bad English. The second thing you have to look is what are the reference voltages. What is the minus reference voltage and what is the plus reference voltage. So in this particular example, the minus reference voltage for me is equal to 0 volts and the plus reference voltage is equal to 5 volts. So I can have a maximum value of 5 volts on the input of the AD converter, and the minimum is going to be 0 volts. Now, okay, so I have, let me see here, 0 and 5 volts over here. But what about the digital values? When does it grow? How does it grow from binary 0 to binary 1, the binary 2, binary 3 and binary 4? Well, it is easy. First you have to subtract Vref plus with Vref minus, so that is equal to 5 volts if you have this particular reference voltage. So that is equal to 5 volts. And you have to divide by 1024 in this particular situation, because you can have a 10-bit binary number over here. And 5 divided by 1024 is going to be equal to about 48.82 millivolts. So this is this is 4.88 millivolts. So if you have if you have 0 on the input of the AD converter, then the output is gonna be all zeros of the digit. So all here would be zeros from B1, from B0, B1 to B9, all zeros if you have a 0 voltage level on the input. But if you have 4.88 millivolts, then it's gonna be binary 1. So this B0 is gonna be 1, and it grows on every 4.88 millivolts on the input. This you will have one binary larger number, and the maximum is gonna be, and if you have 5 volts on the input, then this all goes to 1. Okay, now so that's basically it for that is what you want to look at. That's first one you want to look at is the resolution and what are the reference voltages. Now, I want to say here that this particular microcontroller, you can set the reference here on Vref plus and Vref minus. That is the plus voltage of the AD converter, and that is equal to minus voltage. This shouldn't go below minus 0.3 volts, and this shouldn't go above, let's see how much, 5.3 volts. So those are the maximum values. But if you want reference voltage, for example, Vref minus is equal to 1 and Vref plus equal to 3, then you have to do some specific things to the registers of this PIC microcontroller. And if you go to the datasheet of this microcontroller, which is on the microchip site, PIC16F887, you have to go to the AD conversion and look at the registers. So if you want to change the register, the reference values, go to this register called ADCON1 and look at this particular pins over here, RW0, RW0, this says here that you can specify the voltage reference externally. So if I bring 1 on this 5th bit over here, then I can externally bring a negative reference voltage on this microcontroller. So I have to bring if I said this would be 1, I have to bring one voltage of 1 volt to RA2. If I want external voltage on Vref plus, which is different from the voltage that I am power supplying this PIC microcontroller, then I have to on this particular bit over here, on the 4th bit of this register, I have to bring logical 1, and then I can externally bring the reference voltage on this particular microcontroller. In the future, I'm gonna do some examples like that. Okay, now let's see the code. I think that is the most important thing to see now. So void main is basic stuff, just starts the program. Now I have two long values. So long is a number between I forget, and I call this variable millivolts, which is a long, so that is a number, and I have V input, so that is another variable name. Ansel is equal to 1. Why? Because let's not forget the Ansel registers. This microcontroller has an Ansel register which you can use to configure these pins that could be either digital or analog. So if I bring 1 to a specific pin of this Ansel register, it is gonna be an analog input-output pin. So if I want A0 or AN0 to be an analog input, I have to bring this value 1 to it. So that is why Ansel here in my code is equal to 1. But if all the rest is equal to 0, I don't need them to be digital or analog. And I put the pin over here, tris A F0. So this is referred to the RA0 pin over here, the 0th pin of the register A, as an input. Okay, so tris D is equal to output, port D is equal to 0. So now here is the fun part. Finally, microelectronica has libraries that you can use. It saves time. So you go here, mikroC Pro for PIC libraries, and click Adc Libraries, and there's 3 library twins you have to look. Void Adc initialize over here just initialize the AD converter. I use it before the main program. Adc get sample, I'm not going to use it right now, and Adc read. So Adc read is going to convert analog to digital value, and I can later on and that's practically it. So it reads the analog value and converts it to a digital value. So let's look at the code over here. Now this is just initializing the ADC converter, and here is the endless loop. So on this variable called V input, I'm going to read the analog value and I convert it to a digital value. Okay, now I have a number. I have another value called millivolts that is equal to this input over here, variable over here, times 5000 divided by 1024. So why did I did this? For example, if I have an input of 5 volts over here, then this here is gonna read 1024 and then I have, if I have a value of 5 over here, I have 1024, and 1024 times 5000 divided by 1024 is gonna be 5000, and that is equal to 5 volts. If I have 0, then I will have 0 millivolts. So this is the resolution I get from the ADC read, which can be between 0 or 1024 if the resolution is 10 bits. So that is decimal 1024 maximum values. And yeah, if I multiply that with 5000 and divide it by 1024, I get the value in millivolts, which is good for me. Now here I have these 5 if statements. Now I read, if the millivolts value, if I get between 0 and 1000, then the port D will be equal to 1. So that means that the RD0 is gonna be high. Sorry, let's go to the code. If I get between 1000 and 2000, port D is equal to 2, and then only RD1 is going to be on logical high, every else is going to be logical low. If I get 2000, between 2000 and 3000, then I have port D that is equal to 4, then RD0 here is going to be logical high. And between 3000 and 4000 I have port D that is equal to 8, and 6 if I have 4000 and between 4000 and 5000, then I have that is equal to port D is equal to 16, and only RD4 is going to glow, and that is between 4 and 5 volts, or 4000 or 5000 millivolts. If you wanted to do only in volts, you should only multiply by 5, and yeah, you would get in volts, but you would have to write between 1 and 0, 0 and 2, 2 and 3, 3 and 4, 4 and 5. But in millivolts I think it is a little bit more clear. So when I start the program again, let's see. Here I have 5 volts, and yeah, the last here signalizes that this is like a voltage between 4 and 5 volts. As you can see, here I have now 3.80, so that is below 4. So between 3 and 4 volts I have this diode glowing. Between 2 and 3 I would have here on the middle diode glowing. Between 1 and 2 I would have on RD1, and between 0 and 1 I would have this first one. If you want a little bit more if you want more details, go to this book and read it. I hope you already read this before starting to program microcontrollers. What is how to determine what is the ADC clock period, I don't know how does this work, every register over here, what is ADC on register. I just wanted to tell you about the most important part to know, so you could start to program PIC microcontrollers. I understand if it is hard for you, but don't give up. I also had a lot of problems when I started to learn about PIC microcontrollers. So thank you for watching this video, and see you in my next tutorial. Goodbye.